logic. Uh, in this lecture, we will take one more example. This is also a simple example. Uh, if time permits, we will take one more, and then at the end, I would like to discuss the outcome of the quiz with you, and what were the issues in the quiz, which we had already completed. First of all, let's look at this example. Design a combination logic system for a machine that dispenses either coffee or tea when coins are inserted. Let A, B, and C represent coffee option, tea option, and coin input respectively. The condition for output is such that either coffee or tea will be dispensed when someone inserts the coin and presses the appropriate option button. If, on the other hand, you press both the coffee and tea buttons after inserting the coin, the machine should dispense coffee only. Ensure that your design is economical. I think we have not done this problem before, right?
Yes, sir.
Okay. So ensure that your design is economical. And in the second part of our question, we have design the above logic system if only NAND gates with 2 inputs can be used. It happens sometimes that the NAND gates may be available, and maybe we may have NAND gates with 2 inputs only available, or with quad NAND gates, 4 inputs available. It depends like that, 4 NAND gates on a chip. So it all depends upon the availability of the hardware. So ensure that your design is economical again and tabulate the savings made. Now, we will discuss the first part. We have designed a combinational logic system for a machine that dispenses either coffee or tea when coins are inserted. So A, B, and C are the inputs, and they represent coffee option, tea option, and coin input respectively. So here you have an option for coffee, which is A. You have an option for tea, which is B, and the option for the coin. So a coin is C. And the condition for output is such that either coffee or tea. So here, now we are talking of the outputs. Okay. Now, these were the inputs. Now we are talking of the outputs, and at the outputs, why are we saying outputs and not just output? We would expect that the coffee would be dispensed from a separate nozzle and tea would be dispensed from another nozzle. If both of them use the same nozzle, then there will be a mix-up, and possibly the flavor of coffee may be compromised, or the flavor of tea may be compromised. So it's common sense that we should have 2 separate outputs. So let us say that we have the coffee output here. So coffee out, let's say that this output is X, and we have tea out, and this output is Y. Okay. Now ensure that your I'm sorry. So these are the options before us. Now let us try to prepare the truth table. What are the possible values that can be here in this? So let us first of all, we need more number of rows. So we will group this first, and then we'll slightly reduce the height of this. We can also take it slightly down, yeah, and paste it. Sorry. So this is our grid. Now here, uh, what are the inputs? What are the possible inputs? Now it's very simple logic, but it's preferable that you follow a systematic approach. Say you have 0 here, 0 here, 0. Then 0, 0, 1. 1 means the coin has been put in, but neither coffee nor tea. So here 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. And 1. And now the output will come only when the coin has been pressed. Now if you have a coin input has been activated. So here you are going to have neither tea nor coffee, because although the coin has, uh, it is saying that there will be no coffee or no tea because no option for coffee or tea has been pressed. Only the coin has been provided. Of course, here you are going to have neither coffee nor tea. Okay. Here there is no coin, so neither coffee nor tea. Now, coin has been put in and the option for tea. So tea will come here. This will be, there's no coffee. And then here you have coffee, but the coin is not there. So no output. Here you have the coin put in, option for coffee. Yes, coffee should come, tea should not. Here coffee and tea both have been opted for, but no coin. So you will have no money. Hello, can you hear me? Can all of you hear me?
Yes, sir.
Okay, we had a power failure here. In a span of maybe 3 4 minutes, the power went off 2 3 times. So I'm waiting for the institute to power to the institute net to come up. But in the meanwhile, let's manage with my hotspot, cell phone hotspot. So I hope all of you can see the screen that is being shared with you.
No, sir.
No, sir.
Can you see it now? You can have to
No,
share
sir.
it.
No, sir.
No, sir.
Can you see it now?
Yes, sir.
Okay, so we'll continue. So here the coin is not present, and so even though you have both the options, there is no output. Here the coin is placed, you have pressed both the buttons. Now it says that in that case it should dispense coffee only. So coffee, no tea. So you have, you know that you can um, formulate the logic easily for this. There are less number of ones and more number of zeros. So can you tell me what is the logic? What is the method that you will use? Will you use sum of products or product of sums method? Anybody? Yes. Anybody?
Sum of products is sum of products.
Yes. So we will use the method of sum of products. So first we'll identify the fundamental products corresponding to coffee. So for coffee, uh, what are the products? So for coffee, what is the logic? Not A, not B, and C. Okay. So A, not B, and C. This will give us coffee. Another option will also give us coffee, that is A and B and C. So we'll have to take both these, A and B and C. Okay. And you know how to simplify this. So in this, it's straightforward. You can do it using simple logic. So A and, so you will have not B or B and C. And because not B or B is equal to 1, you will have A and C. So this is the logic for output of coffee. Okay. And for tea, the output is straightforward. There's only one output, not coffee and tea and coin. So not coffee and tea and coin. Okay. So this will give us um, Y, which is the T output. Okay. So I'm sure this is a very easy problem for all of you. You can do it very easily. And I leave it to you to do this part. So this was our part A of the problem. Now what about part B? It says that design the above logic system if only NAND gates with two inputs can be used. Okay. So what are you going to do in this case? Suppose we have to realize coffee output. So first of all, I leave it to you to complete the first part. Okay. So you are to design and ensure that your design is economical. This is something you have to be very particular about. So, so you have to complete the first part, and you also have to prepare. You also have to prepare the sketch. Okay. So I'm not going to do that at the moment for this. So you have to complete part A. This is homework for you. The second part is design the above logic system if only NAND gates with two inputs can be used. Now you can see here we have X equal to A and C. We'll make a copy of this and work on, yeah, we'll work on this copy. So here for the second part, um, sorry. Yeah. So how are you going to implement this logic using NAND gates? Let us try it out first for the coffee output. So we have here X as equal to A and C. Okay. Now we will naturally have to use we'll have to use the Morgans, not the Morgans. We'll have to double complement this. We'll get A and C. So this will be uh, A and C. This is the NAND gate corresponding to that. And we will have to NOT this. Okay. So the first NAND gate, this part will have to be knotted. Okay. How do you do this? So we have inputs A and C. So let us take inputs, take the blue color. So we have inputs. Yeah. And so here we'll have a NAND gate. This is a NAND gate. And this NAND gate has two inputs. The inputs are A from A and C. So I will label this as A and C. This is A and this is C. Okay. And also we will show the output. This is X. I'm sorry, this is the complement of X. Okay. So here we have A, here we have C. We will also put heavier dots on this. Okay. Uh, and we need to NOT this output again. So when you NOT this output again, you have to obtain this NOT using a NAND gate itself, because that's all that is available with you. So you will have to once again take a NAND gate. Okay, and you can connect it. So you will have so not of X NANDed. So this will give you the output will be X. Sorry. So here we have output as X. Hello, are all of you able to see the screen?
Yes, sir.
Yes.
Yes, sir.
You're not able to see the screen? Some of you can see it, some of you can't. Can all of you see the screen?
Yes, sir. Yes, sir.
Okay, okay, we'll proceed. So this is how you can get coffee from this machine. Now, when you need to have tea, so you can you need to do another logic. Yeah, so what should we do if we want tea? So for tea, here also, because we have only NAND gates available, uh, so we will again have to take the complement two times. So that will be not B, not of A and B and C. So you take complement of this twice, so it's the same thing. Okay, but now this is going to have three inputs, and that is not acceptable. So you have to again split it up. So this can be written as, it can be written as uh, A and we can take the combination B and C complement. That is NAND, B NAND C. Okay, and then we take this whole thing. Okay, so this is a better option for us. So we have one NAND gate here and another NAND gate on this combination. So if we do that, we can possibly, we just need to introduce one more line, isn't it? Or we can also make a fresh diagram. So let's make a fresh diagram. So here we have the inputs A, and we have the input B and C. And let us make one NAND gate, and then we can repeat that NAND gate wherever we want. So we will just make one NAND gate here, and this NAND gate wherever we need, we will duplicate it thereafter. So this NAND gate can be selected, will go here, we'll group it. Okay, it's already grouped. So we'll copy it and we'll paste it. So here, first of all, let us write down. We have here A, we have B, and C. These are the inputs. And first, let us implement the logic B NAND C. So we will take input B NAND C. Okay. And then with this output, we can proceed further. We'll do, so this output that we have here is B and C. Okay. And we are going to use this as an input to A and this. So again, we will select and bring this here. This is another NAND gate. Okay. So here, so we'll take the inputs. So one input is from here. And the other input is from A. Okay, so that's it. We'll just adjust the size of the pen. Red dot. So this is coming from A. This is from B. This is from C. Okay, and then we have an output. So the output is corresponding to T. So this is okay. This is Y. I hope you understood this problem well. Anybody having any doubts on this? Hello? Can all of you hear me?
Yes, sir.
Yes. Yeah. So I hope you followed this method, how we can do the simplification. Now I request you all to do this same problem, but now instead of NAND gates, okay, um, you have additional work here. Now instead of NAND gates, you are going to use the other fundamental gate, that is use NOR gate to realize the same logic. For both tea as well as coffee. Okay. So this is your assignment. I will also be posting a more detailed assignment for you, and maybe you will get a week or 10 days to do it. You all have to do it in time. Okay, there will be no late submissions will not be accepted. If they are late, the timestamp will be marked late, and you will not get credit for it. So please be sure, but ensure that you don't blindly copy. You just don't copy, don't plagiarize. Try to do it on your own. It's very easy for us to detect whether you have copied. Okay, so please put in your own effort. That is very important. Now I will also proceed further with the. Let us stop our session. Maybe we can spend some time discussing the